4 pop out, wouldn't I? That 4 would pop out because of chain rule. Yeah? And then when I integrate that, I can integrate that. That's just 1/2 x squared. Power rule, right? Now look at your voodoo, the diagonal. Picture that new integral. 1/2 x squared times this, right? That's actually gotten worse, hasn't it? You're going to have an x squared attached to a sine 4x. You've got some constants. You can pull those out. But do you all see that new integral? I would pull constants out. So I would pull the 1/2 out. I'd pull the -4 out, right? I'd pull that out. But that's what would be in that new integral. And this is not any cleaner or easier to do than this one, right? So that's a bad choice of u. So Lewis's choice was correct to begin with. U is equal to x, and that forces dv to be everything else, which would be your cosine 4x dx. All right, Lewis, what do you got? Du is dx, and v is, drum roll, I agree with the sign. Sine 4x, right? That's what it would have to be, but you're not quite there yet. What else do you need, Lewis? If you take the derivative of this right now, you're not going to get this. Because isn't a 4 going to pop out? 1/4. There you go. Do y'all remember me talking about this last class? Yeah? Does it ring a bell or not? Does this ring a bell? If I integrate cosine of ax, that you're always going to have 1/a out front? Does that not look familiar? No? Okay. Well, let's talk about it then real quick. Think about if you're ever trying to integrate cosine of a number times x. You'll always do the antiderivative of cosine, which is sine, so sine of ax, but you'll always have to scale it by 1/a, because that a is going to pop out when you take the derivative, won't it? And you don't want it there, so you have to scale by 1/a. Thumbs up or down? Okay, now you could almost look at that as like a formula, but I don't want you writing it down. I need you to know this, all right? What about this one? What if we did sine ax? Same thing. We still need a 1/a, right? And then it would be cosine ax, but I'm off a little bit, aren't I? I need this to be negative. And that's just because the antiderivative of sine is negative cosine. We still need the 1/a to knock out that a when it comes out from chain rule. This only works if what's inside here is linear. So if this wasn't linear, this formula won't work. Linear meaning a times x to the first power. If that's x squared, no go. In fact, this will work for just about everything. E to the ax dx. What's the antiderivative of e to anything? Itself. So this should be itself. I think that would make sense to most people, yeah? But if you differentiate that during chain rule, you have to take derivative of ax, which would be a again, and you don't want that there, right? So you just put a little 1/a out here, and that would take care of it. So just get used to that idea that if you see something linear inside, that you're always going to do 1/it to kind of knock it out when you integrate it. Now you saw it after we kind of looked at it, but in general, that's what we've got. Okay, let's get back to where we were here. Lewis, where are we going here with this? Are you happy with the diagonal? Yes? Okay. So tell me what this becomes. So it's this times this. So how would you write that? Would you write x times that, or would you rearrange things? You leave it? Okay, so you can write this. This is not incorrect. But normally, we like to put constants out in front of everything. So like 1/4 x sine 4x. But that's not wrong. Go ahead. Minus. Okay. So 1/4 sine 4x. And then dx, right? And we'll pull the 1/4 on the next step. And I think I'll rearrange that thing up here also. 1/4 x sine 4x, and then minus the 1/4 pops out, 1/4 integral sine 4x. And Lewis, you're telling me you can handle that? So what's the antiderivative, right? What's the antiderivative of this now?
Negative 1/4 negative cosine 4x.
Yeah, negative 1/4 cosine 4x, right? So we have 1/4 x sine 4x minus 1/4 times whatever the antiderivative of this is, which you just said was negative 1/4 cosine of 4x, and then I'm missing one thing, plus c.
So, is that it? We just box it up?
Well, I'm going to clean this up. This is multiplication, and that's a negative times a negative, so I can make that a plus. But then I'll be done. Any questions? Sure? Okay. I meant to ask you all how y'all like me calling on you. Because I'll tell you, I like it. I like it a lot. Do y'all? I feel like it's keeping y'all somewhat engaged. Huh? We'll see. Let me call on everyone, then we can take a poll. There we go. Now, we could check it, right?
Yeah.
I'm not going to. It just becomes too tedious at some point to have to check them every time. All right, good. Shall we move on? Any other volunteers? That's it. We've run out of volunteers. Okay. Who has not been called here? Laura, can I pick on you? Okay. All right, Laura's up. Now, I'm going to give Laura two problems. But I think the first one, I'm just going to leave this up here, Laura, okay? And then I'm going to put a squared on this x. And I just want you to think about it for a second. Squared on the x right there. And just let me know when you have an idea. I don't know. Are you? Do you want to use integration by parts here, Laura? So what's the only other thing we've learned?
Substitution.
Okay, and in substitution you're looking for what? Something is derivative. And you can be off by a constant, make sure the derivative's not trapped. So do you see something in its derivative? Off by a constant. You could do the 4x squared as your u. And the derivative of that is what? 8x. And there's your x. And that would work, right? Moral of the story is what? Every problem you cannot look at, I guess we get tunnel vision because all we're doing is integration by parts right now. So when you're taking a test, that's one of the big challenges, is that you're looking at a problem and you're not going to be prompted, like use integration by parts to do this. You have to kind of go through the Rolodex in your mind of the different things that you could do to this. And if you get fixated on one method, then you can get yourself in trouble. So we're not going to do that problem more. That was your first one. Good job. That would be use substitution, and that's it. So what if I do this instead? I put the squared on that x. Yeah, so now if you try and use basic substitution, you say, okay, u is this, right? The derivative of that is what? 2x. You got a 4x. You're off by a constant, except what? It's trapped. It's trapped in cosine. So you can't ever pull it out. So basic u sub fails. So your only option now, Laura, is at this point, integration by parts. So I'll give you a moment to think about what you want for u and what you want for dv. Okay. And then dv is just everything else?
Yes.
Now, I called on you on purpose because I felt like you would be able to see where this is going to go. So can you tell me, without giving me too much detail, Laura, can you tell me what your diagonal's kind of going to look like? Like, tell me what the diagonal's going to have in it. What? du and dv, right? It'll have this one and this one. So tell me about this one right here.
So this one's going to be pretty simple.
It's going to have an x, though, right? It's linear. And then this one, when you integrate, it's going to have your sign. So you're going to have a sign, and you're also going to have an x.
Oh, okay. So that's a problem.
That's a problem, but we just did that, didn't we? Didn't we just do x with a sign? We're going to have to do integration by parts twice. That's what we're going to have to do. It's kind of like the first time we do it, we're going to take that x squared down to an x. And the second time we do it, we're going to take the x down to a 1 or a dx. So this is going to require 2 iterations of integration by parts. Okay, Laura, I'm going to fill this out. du is, go ahead, 2x dx, and then v is, yeah, you're right. No dx, yeah. Plus c, good. Now it should be plus c, right? Technically it should be plus c, but we're just going to remember that and at the very end throw a c on. We don't want to tack this c on through the whole problem. All right, good. Now go to the formula, ultraviolet minus voodoo. Let's write it out. So sure, whenever.
So the ultraviolet is x squared
Uh-huh.
1/4 times 1/4 sine x.
Okay, so I'm going to write it like that.
And then minus the integral of 1/4 sine 4x times
2x dx. Good. Everyone good with that? Now, Laura, let's take care of constants. Let's just take all constants out. So what would we have?
Oh, so we can, so out of that integral,
Uh-huh.
let's take a 1/2.
Take a 1/2 out, right? And so it'll become minus 1/2 integral. And I'm going to kind of rearrange the order if that's okay. I like to always put like the less complicated thing out front. So I'm going to put x sine 4x dx. So the 2 and the 1/4 came out as a 1/2. Are we all on board? And then we sit there and we look at this and we go, this isn't doable unless we apply integration by parts again. So I'm going to start completely over. And if I were doing this work on a page, unfortunately I have to cram everything into this board to get it on camera. But if I were working on a piece of paper right now, I would have all this work that I've done with my little table, wherever it is. And at this point, I'd have that integral sitting here that we're looking at. And I would either go to a different page or give myself plenty of room. And what I would do is start a new problem, x sine 4x dx, and start working this through. And once I get my answer, I'm going to come back in here and plug it in. That's how I'm going to write it down. All right? So I'm kind of like at a pause point right now. And I'm going to just kind of go to a new piece of paper. And here's my new piece of paper over here. This would be considered kind of like scratch work. I'm going to leave that there. Well, no, I don't need this one. This is where I am, right? So going to a new piece of paper, and I'm trying to find the integral of x sine 4x dx. Yep, we're just going to go again, right? And you're choosing x to be u because You understand that that's going to go to dx, and you're happy with that now, right?
It looks good.
It looked good. All right. So du then is dx. dv is the stuff that was left, sine 4x dx. And then you've got to integrate at least one more time. So what's that going to be there? Negative 1/4 cosine 4x. That's all right. If you just remember, all your dx's are always going to be on the bottom row, and the top row will never have dx in it. All right. So now this, okay, that becomes, by the formula, ultraviolet. So this times this, so negative 1/4 x cosine 4x minus integral, go ahead, Laura, what do we got in there?
Negative 1/4 cosine 4x.
Dx, good. Constants out now. Let's pull constants out. So pop a negative 1/4 out, that's just going to become plus 1/4. Agreed? Push this out. Plus a fourth. It's gone. I'm saving myself some room. That's your next line.
So, didn't we have like a negative 1/2 in front of that?
Yeah, so look, you know how I did this in purple here? We are just doing this integral. We are not doing the negative 1/2 yet. We are going to take this answer, whatever it is, and we're going to slap it right here. But we got to get the answer first. So you still have an integral to do here, don't you? Yeah. So that becomes negative 1/4 x cosine 4x plus a fourth, and then times, Laura, the antiderivative of cosine 4x.
1/4 sine 4x.
Mm-hmm. And then plus c, right? I'm going to hold off on the c. I'm just going to tack a c on at the very end. We happy with that, everyone? This integral right here becomes this. And that needs to get pasted in right there. So I'm ready to go back to this now, all right? I'm going to rewrite this now. So this now becomes, where, this one?
Yeah.
That came way earlier when we did integration by parts. When we did our voodoo part, we pulled that constant out earlier, right? So it has nothing to do with that one. Yeah, so you start to kind of lose track of things because they're in different places, you know, which is why you need to get somewhat of a systematic approach. So I'm going back to this. I'm rewriting what I had here. That's this. That was my original U times V. That was my original ultraviolet. Minus 1/2. And then this entire integral becomes that entire expression. So I'm putting it in brackets just to really stress to you that that negative 1/2 is going to have to distribute. And I never put these together. That's 1/16, isn't it? So 1/16 sine 4x. Close my bracket off. I'll go ahead and throw my plus c on now. We're almost done. We just need to distribute the negative 1/2 through. Do you all see it though? You can, if you leave it like this right now, you can really, you know, if you kind of step back and slap yourself in the face a few times, you can kind of see it. Like this is ultraviolet minus the integral of voodoo, but that integral of voodoo turned into this, which is another ultraviolet minus the integral of voodoo, but that integral you were able